All right, our next talk is also from Google. It's P4HIR towards bridging P4C with MLIR.
Hello, everyone. I'm here to talk about the possibility of using MLIR in building P4 compilers. And the motivation starts from the general problem of building compilers for domain-specific accelerators. And this problem is most prominent in machine learning nowadays. And we are all aware of that in machine learning, there is an increasing demand for these accelerators. And in order to use those accelerators, you need machine learning compilers. And if we look at how these machine learning compilers are built, we might notice MLIR as a common technology. And it turns out MLIR is not machine learning specific. So this makes me wonder if we can leverage MLIR in building P4 compilers. So let's take a closer look at what is MLIR. So there are several misconceptions about MLIR. One is that MLIR is machine learning IR, which it is not. It actually stands for multi-level IR. And second is MLIR a specific IR? That is also not true. It's actually a general framework for building compilers. And it is extensible through user-defined IR libraries called dialects. So it's kind of a tool to build different IRs. And this framework provides a toolbox of common compiler infra and also a core library of reusable dialects and transformations. And a key feature of MLIR is that it allows different levels of abstraction to freely coexist. And that is a main feature that makes it suitable for building domain-specific compilers. And given the time we have, we cannot get into more details, but I have listed some example projects that have used MLIR, both in building machine learning compilers and also in other domains. So the next question is like, why would we consider using MLIR in P4C? And I have thought of several potential reasons. One is to reuse the MLIR common compiler infra that might save some maintenance costs on the P4C side. And second is it might enable extending P4C in some new ways. And third is that this might encourage communication between the two open source communities, which might be a good thing in general. So then the question is, how can we achieve that? And this is just a high-level proposal. So what we see here is a high-level architecture of the current P4C. And the proposal is we can define MLIR dialect. We can call it P4 high-level IR or some other name. But the goal is that we can design this dialect to closely model the existing P4 IR. So we can transform between these two IR. And with a prototype of P4HIR, there are some potential use cases we can think of. One is it's probably possible to build alternative front-end similar to those machine learning frameworks that can be in the form of a programming framework in a host language. Like there are mature examples of using Python to and then build those frameworks in ML compilers. And second is we can further define different dialects that models the backend target. Well, this does not add new values to the existing P4C compiler, but if we aim to use MLIR as a main framework to build P4C, then this might be something we need to do. And another possibility is that might enable integration with external projects that also uses MLIR. And there are two specific examples I want to highlight. One is like there is an LLVM dialect that's built into MLIR. And if we can lower the P4HIR to LLVM dialect, we can get access to the LLVM IR and also all the backend in LLVM. And another one is a circuit project that using that, we can generate some Verilog code, and maybe that can be used to target FPGA targets. So overall, this opens up new possibilities to target new software or hardware targets. And there are also possibilities to define dialects at different abstraction levels, and so maybe a mid-level IR. But all those are like pretty high-level thoughts. But as to the concrete work, I think we can start from like building one single dialect like P4HIR and see how that works. So here is a summary. So the overall goal of this talk is to get the P4 community interested in using MLIR in P4C. And while a full P4C MLIR integration will be a huge project far beyond any personal effort, I think defining a single dialect is relatively straightforward and might be a useful starting point. And we plan to build a P4HIR prototype as an experimental project. And I have opened GitHub issue for further discussions. That's all. Thank you.
Of course,
Yeah, I thought there's
of
no
course,
time
I'm gonna ask you a question about this.
Yeah.
There's no question. It's more like as you talk about the circuit, the CRCT, which is for MLIR, which sits on top of MLIR specifically for Verilog. Go back to the slides you had this.
Oh, that's like
No, I was going to tell you, we're gonna need to have both because one is for the hardware, the MLIR is gonna be for the software, and you're gonna need also to get some kind of intermediate representation, like between the two, like somewhere in the mid-end, that can be able to translate the MLIR to CRCT to do this thing. Because with the one, and you're gonna create a dialect for the P4, and with the other, you can create some kind of a general representation of hardware, like lookup tables, pipelines, and eventually gonna have to use the CRCT to do the specific things for hardware, like a backend compiler.
Yeah, I think
So
that
the
makes
process is
sense.
going to be much more complicated
Yeah,
than
definitely.
just MLIR. That's what I'm going to say.
Yeah, I agree with you.
Yeah.
Yeah, another follow-up question. I'm asking a lot today. I don't know.
Yeah.
So this IR, I think, has a great opportunity for in terms of design and like thinking about design questions. For example, you can think about translating MPL to this IR or eBPF code to this IR, and that requires designing some particular primitives. Is it currently the plan just to have a one-to-one mapping between P4IR and this IR? Or
Yeah, that's my personal plan because I'm not an expert in designing IR, but I think this might be a starting point that if we can map the existing P4IR to the MLIR framework, and then there are opportunities that there might be other MLIR dialect that then there can be transformations between them.
All right, thank you.
Yeah, go ahead. We can do one more.
This is really cool. Let's see, I want to say, so one comment is, I've heard MLIR criticized because it really doesn't impose structure in the same way as other kind of very popular IR stars. It's really sort of a notation for defining IRs with some standard tools. And I guess you just sort of said you're going to just reflect the current P4C IR. Could you speculate a bit on what other IRs might make sense? Like, SSA, for example, is, LLVM is based on SSA. And you can imagine wanting to impose similar conditions on P4 programs. That could interfere with things like resource allocation, though, right? If you generate a bunch of temporaries.
Yeah. I'm guessing like the existing P4C backends might already done some of those works. It's just not in the not in the MLIR framework. Anton has more knowledge on that.
Yeah, let me answer this. Yeah. So the thing is, the LLVM itself, it's Oh, sorry. Yeah, but I can feel this whole doesn't matter. So LLVM itself is pretty low level compared to the current P4C. So the whole idea is to allow to perform high level like reasoning, transformations, and all kind of optimizations. So and as soon as you go down level, so certainly you could do much more like fine-grained things like dealing with like bits and like structs and so on. But well, there is no such thing as header in the LLVM, so period, right? So the whole idea certainly is to have some kind of like common high-level framework to transform and analyze and reason about the thing. But my personal like suggestion is probably it would make sense to try to design the thing from scratch as well, even if it's not like be implemented in such way. But let's probably design the thing as like something that could be extended later. So I already told you, like from my perspective, might be make sense, like this particular design, but overall it should allow eventually to have the complete front end to be based on the MLIR, for example, meaning that we don't need to have the just one dialect. So likely we would want to have like tower of dialects, maybe 2 or 3 or something like that. So one probably like reflecting the core P4, right? So the like desugared thing, but we also need to have defined the like completely entirely like sugared dialect, right? So and eventually have the well, maybe the front end like some other like front end like convert from one dialect to another dialect, right? So that
Maybe we can take it offline.
yeah, certainly. Just, you know, like there are lots of things that could be done here. It's definitely, as I said, a very huge project, but it could provide lots of benefits, but well,